Okay then, I'd like to welcome you all back. I'm here with our 4 method sessions chairs from this morning and this afternoon. We've got Vicky Haynes from Loughborough, David Allenson from Loughborough. We've also got Rakaya Razlan from UCL and Michelle Shipworth also from UCL. I think what we're going to do first is we're going to take some opening statements from the panel, just summing up their methods sessions this morning. For those who didn't attend each one, you can hear about what went on there. So, where should we start?
Well, we had sort of thought that we would just sort of start from the top, so just at the beginning of the day, really. So I was going to start off. So I chaired the session on quantitative methods, which ended up being particularly interesting because we had a nice mixture actually. We had straight quant and then we had mixed methods. So we heard from Sven Hallen from Loughborough, who presented his research question was around motivating factors influencing home energy use. But his philosophy he described as primarily positivist, but including a bit of interpretivist as well. So he was using a mixed methods approach. So he had quantitative measurement of temperature and dwelling and energy use and quantitative predictions of energy use, which then all put together resulted in a bunch of puzzles, which essentially those puzzles really framed his research questions that he then went on to investigate using qualitative methods, so in-depth methods. But he noted that the scary thing about using the qualitative methods was essentially you don't know what the data might throw up. So with the quantitative approach, he had much more of an understanding of what was likely to be coming up. With qualitative, it was like, oh, what's going to be coming up here? And interestingly, we had a psychologist in the audience, the lady there, sorry, I don't know your name, who noted that she had also used mixed methods approach, and her approach was sort of almost the opposite of Sven's approach, where he was using the quant to inform the qual, and she had used the qualitative to very much help to structure and work out exactly what is it that she needed to measure. And then had gone in and actually worked out her experimental design on that basis. So that was rather interesting, and it really kind of, for me, it reflected a talk that I went to at the Royal Statistical Society a number of, loads of years ago actually, where essentially, I think it was the head of ONS was making the point that essentially you can't talk about qual and quant as if one is better than the other, because essentially you need the qualitative, you can't do the quantitative unless you're informed by the qualitative first, and then once you've done the quantitative work, then really you invariably end up with another bunch of puzzles that you need to go and address using qualitative work. So that was kind of the sum of the sort of discussion around the mixed methods. And then Moira Nicholson from UCL gave sort of a very different approach from the methods that she used. Her research question very much tells you a lot about her philosophy and methods, was can we nudge people into switching to smart time of use tariffs? And her philosophy was very much deductive, very clear, so starting from an ultra-clear theory and test, does it work in this situation? And her method strongly quantitative, experimental, a real-world, randomized controlled trial. So, and she gave a lovely example of how you might actually use survey data. So you might use, there was some quantitative work but it was a survey design rather than an experimental design, and actually resulted in being an extremely poor predictor of likely uptake for Green Deal, extremely poor. And that essentially a survey can be very poor at predicting the outcome of, the uptake of a new offering. So experimental design can be extremely strong for this sort of, when you want to understand what the uptake will be. So it can be more reflective of what's likely to happen in the future. So it can be great for estimating the effect of A, if you like, on Z in the real world. So you have very strong internal validity. But she was also really clear that it doesn't say anything beyond that. So it says something, it's super duper at being able to sort of say, this is impacting upon that, but it's not going to be saying anything about the broader world or anything beyond that. And she mentioned as well the absolute imperative of being able to know precisely what it is that A and Z are, and why it is that you think that A might affect Z, and precisely how to measure them, and that is difficult in our area. And this is going to be relating to David's chat a little bit later. And essentially, one of the difficulties, as Moira pointed out, is that in our field, measurement is still problematic. We don't have agreed approaches to measurement. And I would also say that one of the difficulties and one of the reasons why we don't have these agreed approaches is that we don't even have clear and agreed definitions of what it is that we're talking about. One person's thermal comfort equals another person's demand temperature, and one person's demand temperature equals another person's very precise internal average temperature averaged over space and time. So there's lots of things that we need to agree on what it is that we're measuring first, and then how it is that we need to measure it as well. And there's some, I would advocate watching Marcus de Sortoy, his fabulous TV program, Precision, the Measurable Things, is all about super on that. Essentially, the nice thing with a real-world RCT, or randomized control trial, is it's super for external validity as well. So that overcomes some of the criticisms that are often made about RCTs. So you have the external validity as well. But the tricky thing there is that you need generally to be working with external partners. And the problem with some having external partners can be that they might change your research design as you're going along, or in the, as Moira's recently experienced, they might actually pull out at the very last minute once you've already developed half a dozen different extremely good experimental designs. They then pull out, which then puts the research itself at risk, and also you can then have certain ethical issues that you need to address. One of the other important issues that was raised actually in the session was how many interviews make a PhD. There you are. Made a super point about a meta-analysis that you did.
No, it was one that we saw actually, but it was between, I think, 1 and 120 was the average. So
between 1 and 120, so somewhere between that is a good idea. Is what you might see. And his own experience was that although he did a vast number of interviews, 60 interviews for his PhD, only 3 of those ended up yielding the really superb data that formed the foundation of his PhD. So, over to Vicky. Sorry, Rebecca.
Well, this morning I chaired a really interesting session on use of modelling as a methodology to undertake research in and around my PhD, but specifically in the built environment. I had 3 interesting presentations that looked at the application of different modelling methods, as well as in some cases the development of algorithms and sort of add-ons to existing methodologies. The first presentation by Özlem looked at the evaluation of refurbishment strategies, and it showed the use of a suite of tools to undertake lots of dynamic modelling, parametric modelling, optimization. I saw some Pareto front-end genetic algorithms, so it really showed kind of what you can do with dynamic modelling in terms of understanding the way by which to evaluate how to refurbish buildings. The one thing that did come up in a lot of Özlem's work was the fact that uncertainty was a big issue, and methods such as sensitivity analysis were really important to kind of make modelling more robust. The second presentation by Jonathan Chambers from the UCL Energy Institute was a bit different. It was more about creating modelling frameworks around large data sets from various sources, and using those data sets to perhaps improve on the generation of EPCs within the UK. Some of the things that he talked about was the need for the creation of robust data pipelines. It was really, really interesting in the sense that it was sort of a step away from normal kind of physics-based modelling. And the last presentation that we had by Christopher specifically looked at Chinese cities, and I thought that was a really good presentation because he's so early on in his research, but is thinking about some quite fundamental aspects to do with the work he's going to be carrying out in the next few years. His main aspect was trying to match kind of some of the modelling that he'd done with real data, and one of the things he pointed out was matching, of course, occupancy and what people do in models with what people do in reality. And the underlying thing that did kind of come up in using modelling is we don't just need to use models and apply them, but we do need to think about perhaps validating or verifying the results that do come out of them. And over to, is it David?
Yeah, thanks. So I was in a great session on measurement, and we had 3 excellent presentations. First of all, Vicky Tink. Where's Vicky? Hello, Vicky. Vicky told us about her work in a matched pair of houses, and because she had test houses, there were no people in them, and so she could fill the houses with lots of instruments and lots of wires and cables. But then she introduced some synthetic occupants to represent the heat gains and other behaviours of the occupants in the houses. Then heard from Lisa Izzat. She told us about measuring heat and moisture transport in brick walls. So there was a kind of common theme between the two projects, but using very different measurement methods across them. And in fact, Lisa was developing a method to measure the moisture content through the wall. And this had originally been a very small part of her research, but it developed actually into a big part of her PhD. And I think what's going to be a really important contribution to knowledge at the end of that. And then Safwan Samsudin, he told us about the thermal comfort work that he was doing. He was exploring differences in the thermal perception of people from different countries. And he was doing this again in a test house, but by inviting groups of students to come and sit in the house to report on their thermal comfort. And then he also had very expensive measurement equipment in the house to try and measure that thermal comfort. So a mixture of qualitative and quantitative assessment of thermal comfort. I jotted down a few themes that I thought crossed all of the project and the projects and the conversations. One of them was the need for careful planning and very good experimental design. The second one was around the problem of gaining accurate measurements, the need to calibrate instruments, and we also talked about the need to develop perhaps standard methods of measurement in some cases. The third one was the difficulties of equipment failure. When you try and measure things in the real world, things go wrong, equipment fails. 4 was problems caused by real people in real buildings, and the way that a lot of these experiments have tried to deliberately avoid the problems of people in buildings. But with thermal comfort, you can't. You absolutely have to bring people into the building to do that. The 5th one was the huge amount of time, effort and cost required to do these measurements, and how easy it was to underestimate this at the beginning of the project. And then finally, that often you end up with the inevitable regret of wishing that you had just measured something that you didn't when you get through to the data analysis stage. Did I miss anything? Anyone wants to add anything from that session? No.
Okay, I chaired the session on qualitative methods. We had 2 excellent presentations. The first from Nasika, who is looking at daylighting in schools and trying to make a match between the quantitative measurement of lighting by using a high dynamic range technique, which is quite a novel technique, with people's perception of that lighting. So she's mixing both qualitative methods and quantitative data. The other presentation was from Claire Hammer, and she reported on her MRES study, which was really doing a historical perspective of why the UK has so many gas boilers using actor network theory, which is essentially an approach to look at the whole kind of network of how the social and the technical aspects come together. Her work's particularly important in looking if we're going to transition into new technologies like heat pumps, energy storage and so on, to kind of see why is it that we've got such a, in the UK at least, such a sort of static heat delivery system, and how on earth can we disrupt that to be able to change for the future. So 2 really different topics, but both of them looking at both social and technical aspects and trying to combine that. So although our session was entitled Qualitative Methods, both have used kind of qualitative analysis, either through questionnaires and focus groups, Nasika and Claire have looked at old magazines and plumbing handbooks and so on, so taking a qualitative approach to documented evidence, both combining with measurement data in some way as well. So we had a bit of a discussion about the order in which you might collect that data, and I think that resonates with what Michelle was saying, quite often taking a bit of qualitative data to get an understanding about what might be going on, deciding then what to go and measure, and then coming back and supporting that with more qualitative information to understand what that all means. And that moved us on to a discussion about the difference between understanding what's happening and why it's happening. And making sense of the data and this understanding causality. So what is happening, can we measure what's happening, and then can we explain what's happening? And the qualitative investigations allowing us really to be able to do that sense making. We then moved on to kind of asking about, do we really need to understand why, and do we need to ask people about why? Can you just not measure what happens, and maybe that would be sufficient? We also talked about whether people were rational actors or not. That resonated with a conversation at presentation this morning. And essentially in our energy system, it's a very complex socio-technical system, and therefore maybe there is rationality and maybe there's reason about why people do things, but it's quite difficult to unpick that sometimes, and it's not constant. So it's not so easy to run a controlled experiment because you have so many variables. Is there anything else I want to add? No, I think the only thing that I picked up, and I think it was Nasika used an expression, and we talked about socio-technical systems, but she used a really nice expression. She talked about this in-between area, which I think was this kind of mix between social and technical, the measurement, the modelling, and the human. I thought that was a really nice way of kind of describing it. We struggle with language sometimes and what we're talking about, but what we're talking about here is this in-between area, and I think we shouldn't lose sight of the fact that we are probably unusual in exploring this space with such comfort. I think if you go in and look at other research that's going on in energy demand, it's much more pockets of expertise in the measurement or the modelling or the social understanding. I think within the LOLO CDT in particular, but all the presentations I've seen today, embrace this as the normal way of thinking. And I don't think we should lose sight of the fact that this is actually unusual.
Should we take some questions from the floor? Anyone? Or comments?
We were having a discussion as well between us just before we started on this, and we were sort of talking about mixed methods and when one might and might not use mixed methods. So I thought it might be nice to sort of touch on that. And it was interesting because all of us sort of could see the value in mixed methods approaches, but we felt that it came with a huge health warning that it can be extremely difficult to get sufficiently across each of the methods to be able to then say something with confidence using those methods. And that the best work using a mixed methods approach needed to then be even more focused than if you like, normal research. But that sometimes, essentially, the nature of the research question was just that the only sensible approach was to use a mixed methods approach, but it came with health warnings.
I'd like to add to that. I think across the panel, combinations of us have worked together, but we all come from very distinctive backgrounds, and that's the contribution that we bring when we work together. So I think it's important to kind of have an understanding about where you think you sit, what your area of expertise is, and be true to that. So you don't try and dilute your understanding, your area, because you understand your literature, your methods, your research area better than anybody. And the trick is to be able to be understanding and sympathetic and tolerant and interested in how these things fit together, but not necessarily then to go and do those things yourself.
I'm just wondering what the panel think of Envival as a program to help understand or help organise particularly qualitative data.
I think there's only going to be two of us going to answer that.
Well, I have no experience.
Oh, okay, so I'll answer that one then. It's, if you don't know, it's a piece of software that allows you to sort qualitative data, so you can import things like transcripts, but also video, photos, audio, and so on. And you can then associate particular parts of that information in its broadest sense, and you can tag it. So it's a bit like having all of your data in its widest variety and using a highlighter a lot of highlighters and say, right, these bits are all about one thing, and this is also about the same thing, and highlighting that, and then highlighting that. So essentially you go through and you can code your data by saying, this was all that respondent 1 said, this is all that respondent 2 said, this is respondent 3, and then you might say this is what respondent 1 said about their attitude towards energy saving, this is what respondent 2 said about attitudes to energy saving, this is respondent 3, and so on. And then you go through it again and say, well, it's not just energy saving, but let's say this is what they said about renewables, and so that might be contained within the bit you've already coded, or it might be a new thing. So essentially you kind of make multiple passes through your data, highlighting in an electronic way things that link together. And you can, if you've got a video or an image, you can say, well, this clip or this part of the image is part of, part of that same thing. And then you can draw out, with some ease, things that link together. So you say, tell me everything that anybody said about, the use of heat pumps or whatever, depending on what it is that you've coded. So it doesn't do any thinking for you. You have to do all the thinking. You have to decide what your codes are going to be, the nodes are going to be called, are going to be, and how you might group it. So there's still that interpretation. It's just a way of managing a lot of data. So if you've only got a small amount of data, it's perfectly good to go with the highlighter or whatever it might be. And I've done manual coding of data, and it's perfectly adequate. If you've got a lot of data, it does help you manage that. And if you've got a lot of data that you might want to go back over time, or you want more than one person to analyse, or you want to analyse more than once, then it's very good for that. So I'll give you an example of my own PhD student who did, I think forgive me for this, but she had 20 participants. She did 2 in-depth interviews with them. She coded it all in NVivo, and we made her code it all again for validity. And so she had to code the whole data twice, and it's quite an involved, boring process. So, so she went through that twice to check that she had interpreted it in a similar way. We also took a subsample of her data, and one of her other supervisor coded it as well.